Today is February the 8th, 1994. I'm Blake Hailey, and we're pleased to have with us Dr. Harbans Lal, the chair of the Pharmacology Department here at the University of North Texas Health Science Center at Fort Worth. And we're making this videotape in the Gibson D. Lewis Library in the Biotech Communications Center. Dr. Lal, I appreciate you taking time out of your, I know, extremely busy schedule to work with us today.
You're welcome, Mr. Hailey.
If we could, I'd like to start with perhaps your prior experience. I know you came to TCOM in 1980. Perhaps you would like to go back and tell some of your experiences leading up to your time here at TCOM.
I came to Fort Worth from Rhode Island. And let me digress a little bit. I was born in a place which is now in Pakistan. It was United India at the time of my birth. Then the country was partitioned into two. In 1947, we moved to what we call Indian side. Once I was uprooted from my hometown, I made up my mind to not stop anywhere else until I reach the best place there is for my personal and career development. And I made up my mind to come to United States. I went to school in India, had completed a Bachelor of Pharmacy degree at Punjab University, and moved to United States, where I got my master's degree at University of Kansas in pharmacology and toxicology, and then moved to University of Chicago. My reason for going to University of Chicago at that time was that it was an excellent university for one, but also that was the university which pioneered use of radioactive isotopes in pharmacology research, and I was very anxious to learn that technology to apply in my future research and perhaps go to India and set up a lab where that new technology can be used. So that was the kind of reason, but turned out to be that I had a very good graduate education at University of Chicago, where I graduated in 1962 and was hired by a place called Illinois Institute of Technology Research Institute, where I immediately took over a project which was funded by Department of Defense related to biological warfare agents, where my job was to determine the mechanisms of action of these substances. I stayed there till 1965, when I was offered a position of associate professor at University of Kansas, from where I obtained my master's degree, where I was a graduate student one time. I took that position, started working there until I realized that I wanted to move to a little bit situation where there's a greater educational environments in terms of the several medical school, colleges, and I was offered a position to start a pharmacology program at University of Rhode Island, and I saw this was between New York City and in Boston, with a number of medical school research institutions, and still I did not have to live in Boston or New York. I lived in a kind of a suburb, a beautiful place in Rhode Island. And there we stayed till 1967. We moved there to 1967 actually, and several years I worked there, was promoted to a full professorship. Then somewhat nominated my name at several places. One of the places was at Texas College of Osteopathic Medicine. When I was a graduate student at University of Chicago, I graduated and I wanted to participate in teaching to acquire the teaching skill, but University of Chicago faculty size was very large, and my chairman told me that it will take a while before my turn will come to participate in medical student teaching. And I looked around other opportunities, and I found that a few blocks away was Chicago College of Osteopathic Medicine. Chairman of Physiology and Pharmacology, Dr. Kelso, was known to me, And I went to him, and he offered me opportunity that I could come and teach pharmacology there on volunteer basis. So I did that kind of on the side. Began my pharmacology teaching at osteopathic school at that time. So I was familiar with the school somewhat.
And this was in 67?
That is in 62, 63.
Oh, okay, okay.
When in late 60s or late 70s, when opportunity came up to consider to move to Texas College of Osteopathic Medicine, I was familiar with the osteopathic school philosophy, and I came and looked at the facilities and the plan, and I thought that is the place I want to build my career, because I saw an opportunity where I could start at a base level and get things accomplished which will be very reinforcing for me and for the rest of my life. And that is how I accepted the position here. I came here from Rhode Island. Dr. Willard was the president who hired me, and when we negotiated the position, one of the items came up. Dr. Willard wanted to strengthen the basic sciences department, and since we were small school, his idea, which coincided with my idea, that each department should concentrate on a particular discipline, not dilute itself. And my background was in neurosciences, and he said, okay, pharmacology department can develop the neuropharmacology, neurosciences. After I came here, similar president's wish was the physiology department develops into another competency, and that was the cardiovascular system. Their strength was. College hired Dr. Carl Jones, who brought in his strength, faculty strength, and developed an excellent department with the competency in coronary circulation and cardiovascular diseases. So TCOM started with basic sciences, developing different specialization and competencies in each of the basic sciences department. That fitted very well into my philosophy of career development and the college administration. And that is how it started, and my background coming to TCOM.
Oh, that's great. We're very fortunate to have you here as well.
I am pleased to.
Perhaps, if you would, could you go into over the years, some of the research you've done, and possibly some research that you're involved in currently?
I think my research interest can be divided into two major categories. One is in the area of aging, and other is in the area of substance abuse. In the area of aging, again, there are two major efforts. I should make it a point that in pharmacology, our job is to develop new and safe drugs for treatment of various diseases. And in area of aging, then our interest was, one, what are the bases for deterioration of brain functions with aging? And second was, how can we use pharmacological knowledge and advances to retard and remediate those changes. In the first case, my research started with several years ago with neuropathology of brain aging, which resulted from aging, and I followed up accumulation of pigments in the brain called lipofuscin pigments, and these pigments developed in the nerve cells and in heart cells as a function of age. And I thought that this is a metabolic garbage which accumulates in the nerve cell, and they kind of chokes the nerve cell and it cannot perform its functions. My research started with that and moved into neuroimmunology. We found that with aging, particularly in senile aged population, there developed some antibodies which circulated in the blood and which were specific to nerve proteins, brain proteins, particularly in the brain. And it was very intriguing because brain is kind of immunologically protected, and all immune systems develop in the blood, and brain is protected from them. And it was kind of very intriguing why there should be antibodies circulating in the blood which were specific to proteins in the brain and perhaps produce brain damage as a function of age, because they were found only in aged animals, and they are found in mice, rats, monkeys, humans, throughout the animal kingdom. That interest continues until today, where we are in process of correlating the presence of those antibodies with the neuropathology in aging and some mental dysfunction, particularly dysfunction of learning and memory. As you know, with aging we begin to lose our memory functions. Is it that it's a autoimmune disease, that the sum of the brain proteins become antigenic, so body recognizes them as foreign proteins because they were not present before. They were generated as a wear and tear with aging, the reason we do not know, and then they start stimulating formation of antibodies which are kind of to destroy them. We are studying those proteins in the brain and the antibodies which are circulating in the circulation, and correlating them with the memory dysfunctions and see if we can manipulate them. More recently, my interest in that area was developed in the free radical formation. But a lot of research is coming into the literature which says that with the body functions, metabolic functions, there are produced some oxygen byproducts which are toxic to brain cells, to all cells as a matter of fact, particularly to membranes. And this toxicity is very small, but it kind of accumulates over time, over years. And many of the damages may be caused by this mechanism. So our interest moved to that direction. There's a lot of research going on, but very little on the brain. A lot more known as to free radical damage done in other organs and other cells, but very little is known about the brain. And I think we are starting a field where brain is the target for study. And we found that there are a lot of damage in brain cells which is specific to various brain areas, depending on which areas are more exposed to metabolic reactions which produce free radicals and oxygen byproducts. Here our objective is to first to localize where those reactions are taking place. Also we find that the free radical damage increases with age and is correlated with some neuropathology and perhaps correlated with the dysfunctions or deterioration of brain functions developed with aging. As I said in the beginning, our objective is to find the treatments which can retard these changes based upon aging, or if they have already occurred, can we reverse some of the changes. In that case, we have adopted two approaches. One is caloric restriction. Idea was that basically is the metabolism of the calorie generating substance in the body which produce oxygen byproduct. We eat, we consume food, they are metabolized. During this metabolic process, the oxygen byproducts are generated. So if an individual consumes less calories and metabolize less calories, will that produce then less damage? And if the aging is related to the free radical damage, then the longevity will increase. And as a result, this does happen. Caloric restricted animals live anywhere from 20 to 100% longer than their counterpart control, who are given unlimited calories to consume. So I think we optimize the calories in an experimental group of animals. And we also find there that many free radical mediated brain damages are retarded in those animals. And in those animals also there is a retardation of the process of deterioration in memory and learning function. So we are very excited about it. Other labs have reported that the caloric restriction almost eliminates certain types of cancers in mice and in rats. And research is being undertaken in higher animals at this stage. Since we are pharmacology department, our specialization is drugs, so we are currently working on the drugs which may prevent the free radical formation and increase the productive longevity. Also, we are interested in the drugs which promote the health of cholinergic cells. Now, in brain there are cells which communicate with each other through chemical processes, and there are many chemicals are involved. One of the chemicals called acetylcholine is involved in many brain processes, and there has been data that these cells degenerate during aging. We are studying the drugs and the chemicals which promote the health of these cells. Number one, to reduce the rate of their degeneration and also promote the health of the remaining cells so they can be better functional. There is also evidence that there are some substances produced in the body which inhibit memory process, as there are substances which promote memory process. So there's a balance of these substances. We are producing drugs and investigating them which affect this balance in a manner that the amnesic effect of these chemicals is reduced or retarded, so we can live longer with our intact memory or reduce the deterioration of memory, which is a major function after we conquer the heart disease and cancer and start living longer. If brain gives away and the memory is not there, the quality of life will be not worth living. And to improve the quality of life, we need to keep the brain functioning and intact. So these are our area in terms of the aging research. Our other major area is
so you're on the cutting edge then of that type of research.
We are very excited and we are very reinforced by the results we are getting and the grant support we are getting from National Institute of Health and other agencies. Our other area is substance abuse. Before I came here, my target of research was heroin abuse. And there I was studying the mechanism of dependence, why people become addicted to heroin. And my major targets were that there are two reasons. One, that there are people begin to experiment with drugs of abuse, and those are variety of reasons. But the next stage is that they get hooked to the drugs. Now, why do they get hooked to the drugs? Because these drugs produce some brain changes. Also, their lifestyle and environments of people and their surroundings kind of become conditions to drug taking. My emphasis was on that, and I, as early as 25 years ago, produced hard data in animals that animals can be trained to produce conditioned effects of drugs of abuse. During my study, I found out that what was known at the time of Pavlov, that if you pair an environment such as a bell and a food, and then bell starts producing its self-salivation, which will originally be produced by food. This is a pairing effect. I started doing research and got some results which suggested that sometime and many times in case of pharmacology, the conditioned effects are not like the unconditioned effect but are opposite to conditioned effect. And this area was developed because of use of pharmacological tool. For example, if an individual takes heroin, it raises the body temperature. Now, if this heroin taking is associated with some environmental event repeatedly and systematically, this particular event now come to acquire a property of eliciting a heroin-like reaction in the body. And one would expect that what is happening is that when you produce this environmental stimulus change, individual will feel as if individual has taken heroin without taking heroin.
Oh, interesting.
That was published, and we thought that that is what is happening in terms of relapse. People who are detoxified and then went home to their environments, when they were placed in the same environment where they used to inject heroin, those environments elicited heroin-like feeling in their body, and they were on abuse again. And that was one of the reasons for their relapses, continued relapses. Even they were drug-free with respect to the chemically they were not taking drug, but their environments were producing drug-like reaction. That led us to a logic saying, how do these environmental stimuli produce drug-like reaction? Well, one possibility is that these stimuli release the body's own drugs. We published this in early 70s, late 60s, these data, even before when the endorphins and the body's own morphines were chemically identified through these behavioral experiments. When I came to Fort Worth, one of the exciting things is that Dr. Still, who is considered father of osteopathic philosophy, promoted the fact that the body produces its own medicines, but people ignored that fact. That body is a walking pharmacy, and he called it God's pharmacy. So I thought I had a tool and mechanism by which I can produce scientific data supporting those hypotheses of Dr. Still. That body has many chemicals, hundreds and thousands of chemicals present in brain and rest of the body, which are released and used by the body to treat itself. And can physician learn to facilitate body's ability to use these medicines? And that was one attraction to come to this college, that where this kind of research will be more appreciated and supported, and it was supported. As I said, I started with the heroin. One was the conditioning effect. Other was I studied the chemical changes in the brain produced by heroin and substances of abuse, and develop drugs, work on the drugs which will be used to treat substance abuse. And at one time thought that you could not treat a heroin addiction because only substances which could block the cold turkey was heroin-like substances. And I think our lab produced first evidence that you could produce non-narcotic drugs which will block the cold turkey. And we published the data on a drug called haloperidol. Those days it produced some side effects, did not become popular and were not used for too long. But then we also came up with a drug called clonidine, and that drug is still used to detoxify heroin addicts. Not only that, its use is now extended to detoxify many other drugs, including smoking and nicotine. So in the substance abuse, when I came here, I more concentrated on how to measure the subjective effect of drugs. One of the deficiency in the substance abuse research was that whereas in humans their habit was maintained because of the subjective effect of the drugs. They were taking the drug because they produce euphoria, pleasant effect. They were also taking the drug because if they did not take, they went into abstinence, which was very unpleasant. It produced very unpleasant effect, and people are afraid of it. And they were taking the drug to avoid precipitation of that situation. But that could not be measured in animals, and only human can tell you whether they are feeling good or they are feeling bad. And that way it could not be measured. So our emphasis was to develop animal models where you could measure subjective effect. There was a lot of debate in the scientific community about the methods we proposed in the beginning. Whenever you propose a new thing, there's a lot of debate. But now community accepts that, and there are close to 100 labs all over the world which are using those methods which were developed here in measuring subjective effects of substance abuse and other drugs in animals. And that was a contribution of this institution and the scientists working here. I think that summarizes the two major areas of the research emphasis that we have at the University of North Texas Health Science Center in Pharmacology Department.
Oh, definitely, and very good synopsis at that. You're also editor of Drug Development Research, a publication. Is that correct? Or you were at one time?
Yes,
Could you go into that and some of your publishing?
In the beginning, when I started my career in pharmacology, I was very much interested in the drug discovery and drug development. And I felt that the people who discover drugs, who are located in the drug industry most of the time, was considered kind of the people who are working in applied sciences, and they were not that much respected as compared to the people who did pure science at the universities. And that was not right. I wanted to provide a platform for these people to publish their data and respect it, which data may be directly geared towards discovery of drugs. I talked to a publisher and a colleague of mine, Dr. Stuart Fielding. We formed a team and we started a series of books called Industrial Pharmacology. That was a series we started to cover the drug discovery research. Through that experience, we realized that that series was not enough, because a book came after a few months and the drug discovery area was developing very fast. We need to publish something monthly basis. We both of us then formulated a plan, and we were invited by several publishers, and we selected Alan Liss. Alan Liss was a friend of mine, and he liked the idea and he said he will support it. And we came up with a journal called Drug Development Research, and it was first published in 1980. Began its publication. That's the year I moved here.
Right.
There were some questions in the mind of publisher that if he publishes a journal from an osteopathic college, what will be the image and rest of the peer group, what will they think of it, etc. But I assured him that if I am moving to osteopathic institution, I made it sure that scientifically there is no question, and people are somewhat ignorant about what happens in osteopathic colleges, and that part of our role is to establish that we are a medical school like any other medical school in this respect of promotion of the scientific research and medical sciences, and I insisted that we publish the journal from this institution. And publisher went along, and journal was started in 1980. During that period, I also published my own research in many other journals. I have close to 400 reviewed papers published. Also, in the last 25 years, I published, edited, co-edited, written close to 30 books in advances in pharmacology, various areas. And that has been very rewarding to me and very occupying intellectually. The journal is doing very well. I edited that for 13 to 14 years, and then I thought this time has come for younger generation to take over. So this year I resigned from that position, and the publisher appointed new editors for that journal.
Oh, I wasn't aware of that. I know in looking through your CV, which is very extensive, I did see quite a few books, and I was very impressed with what publishing you have done. I'd like to, if we could, move into the Health Science Center scheme of things and ask you about the success of this Health Science Center, and do you think this was the right time for TCOM to become a Health Science Center?
Blake, this is my view is as follows about this situation. When I moved here, this place was Health Science Center. For a purpose of history, I still retain a pad of paper in my suitcase somewhere where the letterhead that I first time used when I came here said that was the North Texas State University at that time,
right.
North NTSU Health Science Center. That was the letterhead that I used when I came here, and this was Health Science Center. And through the history, it moved away somewhat from being health science center, and I do not know the precise reason, but my interpretation is the reasons were to reduce the kind of bureaucracy involved with that concept, and it became a full-fledged, independently standing medical school. And then it was realized that in future direction, all medical schools are going towards the direction of health sciences centers associated very intimately with a university. We are fortunate that we are associated with a state university, which is a very big plus. And that was the reason that the President has been very active for several years, moving these institutions toward becoming health sciences center again, which I would say. And we are very pleased that we are health sciences center. The way the medical services are moving and medical education is moving, and the promotion and development of health provider, health science professionals is moving, it will be very difficult for a medical school to be a freestanding medical school by itself.
Right.
Because we are required to produce nurses, allied health scientists, public health people, the Ph.D. people, the teachers, researchers, and physician direct providers of health care. And they all have to be produced on one campus, one institution, where they all go out with one philosophy. We can't produce physician with one particular philosophy and then they go work with the physician assistant and nurses who have never heard of their philosophy. Mm-hmm. So it would be nice that the same faculty, same institution provide personnel for health services at all levels. And we are very pleased that we are Health Sciences Center and the institution is moving to that direction.
How do you see this particular health science center? Do you see it being different from the other health science centers in the state of Texas? I know you mentioned earlier the national picture. How do you see it in Texas?
Well, we are the newest health science center in that respect, and at present we are the smallest health science center. So there's a beauty in the smallness, but also it has a challenge and a lot of potentials for growth, which other health science centers do not have at this time because they have reached their potential. We are at right time and right place. So if we are going to grow now, we will grow in what is needed today. So we will be the health science center of the future, for which opportunity is if you start at base level rather than convert something which has already been established. So we are very excited that we are at the starting point of a new health science center, which is small but which will grow, and which will grow under the new directions of 20th century or 21st century. That opportunity by itself is very exciting.
Do you see some other challenges that lie ahead for the Health Science Center and you as well?
Well, there is our Health Sciences Center's main component is Texas College of Osteopathic Medicine. And that way we provide a distinct philosophy of medical care. I divide the medical services into two categories. One is the technology and one is the philosophy. Medical technology is same. All medical schools have the same technology, same equipment, same devices. Mm-hmm. But the philosophy differs from school to school. And I think we can provide a special philosophy which again is there at the right time, at right place. This is the time where medicine, which considers the patients and human as a whole human being, where physician assisting the body to cure itself, to impart this philosophy in physicians and in future perhaps in physician assistant, pharmacists, nurses, allied health sciences. This is the opportunity. Mm-hmm. And hopefully we will direct our research and basic sciences also, which amplifies on that philosophy. So that's a very exciting opportunity for this health science center. Future lies in many things. I think we are at the brink of making teaching innovations. Our teaching mode will change of all medical schools, and we are all the level we are changing. The computer technology is used. We will be living in the virtual reality in the computer technology where instructions can be individualized to the person's potential. Our administration is pushing to develop centers and institutes. As I mentioned, when I came here, we had departments which specialize in certain areas, and we were very successful. But now the time has come where interdepartmental cooperation increases so that we work on projects and get the project grants. We do not have any project grants at this center at this time. And project grants and centers require several departments interact together. So Dean Cohn is very much pushing and very timely. His push is very timely that we talk to each other in more interactive way and develop centers. That's why the institution has come up with several centers and institutes. That's a challenge to establish them, get them funded. Biotechnology development is a very, very new for this institution. Dr. Gracie, Associate Dean for Basic Sciences and Research, is pushing that this year, and that is something new. I feel that the United States of America is currently a leading edge in biotechnology development. There are many of the things which are developed here, and other countries have taken over, and Japan has taken over a lot of other technology. But in biotechnology, still we are leader, and we can remain leader for a long time to come. Also, biotechnology brings and produces money which can be used for research and instructional programs. So idea is to package the research innovations of the faculty here into packages which can then be sold for generating money to promote research in those areas and other areas. That's a big challenge. We are going into area of molecular biology. For example, my department has been most of the time until recently exclusively a whole animal researcher, a behavior researcher, whole organ researcher. And we are now changing to our resources towards bringing molecular biology in it, because that is where a lot of development is occurring presently, and a lot of breakthrough will occur, and we want to be part of it. And that's a new challenge for me at this college, to take the pharmacology department to the next century.
So you do see your role then as chair of pharmacology somewhat changing in the next few years then, based on what you just mentioned?
Well, my role is changing in a sense that innovations. When we came here, we innovated computer-assisted instruction. When I came here, other colleges did not have computer-assisted instruction. We pioneered, and we still have our computer-assisted instruction, and now many medical schools use computer-assisted instruction. Now we want to go to the next step and involve more computer technology and develop modules for teaching purposes. That is in the instructional field. My role in the departmental research, we did very well. I think we are a highly funded department. Even at the national level, we are on the top third medical school with respect to the funding from National Institute of Health, with respect to the number of faculty and the funding grants we have. We have people in the study sections, highly recognized by our peer group in that sense. And then my role is that I should now move to the department to the next step, which is combining the whole animal research with the molecular biology, and we made a beginning there, and we are going to that direction. That is a new challenge for me. I feel that if the new challenges are not there, person become less productive and less effective. And instead of living on the past glory, we must have new challenges every year or every 5 years to remain young, alive, very productive and active, and I have enough new challenges carved out for me.
Definitely. You have quite a bit of vision, it sounds like, into the future. Dr. Lal, we have definitely covered a lot of territory here today. I want to ask now if there's anything in my layman's line of questioning that I have missed that you'd like to go into quickly there.
I think I covered most of the things. As on a personal note, we are very happy, me and my family, that we moved to Fort Worth, and I am very pleased that we gathered the faculty which acts as a family within our own department, and we have very close ties both on personal levels and on the scientific level with other departments, and administration is very supportive of the scholarly activity in the college and moving the college to the next century. So, and state of Texas is very generous in terms of supporting us. There are problems which are problems of a growing institution, and we need to struggle every day. But looking at other places, other people, I am very satisfied with my life and the environments, what is happening at this center.
Well, the UNT Health Science Center is definitely a much better place having you here, and I do appreciate you taking the time out of your busy schedule to cover these topics and as much ground as you have, and I want to thank you. I know that this will be definitely helpful to us later on. Thank you for your time.
Thank you for the opportunity, and it was nice talking to you.
And with that, we'll wrap today up, and thanks again, Dr. Lal, and hope to talk with you again soon.
Thank you.